Okay. Oops. Sorry about that. I need a pen. There we go. Um, so the one type of graphical characteristic that we haven't graphical, either way. The one that we haven't talked about is this existence of a slant asymptote. And if you haven't seen the video or written the notes down about horizontal asymptotes, I'd encourage you to go back and do that first. Okay. And I would also encourage you to go back and look at the stuff that we did on vertical asymptotes as well. Okay. When it comes to slant asymptotes, we won't know if the existence of this unless we do the same tests as what we were doing for horizontal asymptotes, and that is by looking at the degree, right? So the degree of the numerator is 1, the degree of the excuse me, 2. The degree of the numerator is 2, the degree of the denominator is 1. So because this number is bigger than this number, we have no horizontal, therefore, we have no horizontal asymptote. But, okay, and this is the one specific case because, I'm going to say because 2 is 1 unit larger than 1, and you're like, okay, what are we in kindergarten here? There is a slant asymptote. Okay, only when the numerator only when the degree of the numerator is exactly 1 larger than the degree of the denominator, when we get this very specific case, we have a slant asymptote. If this was a 3 and this was a 1, we wouldn't have a slant asymptote. Okay. Now, to find the slant asymptote, and again, I would encourage you to come back and check out this video, which has already been posted. It talks about doing long division. Okay. Now, in this very specific case, synthetic division would actually work because this is a linear factor, okay, or a linear binomial, right? We can do synthetic division with linear binomials, okay, but you're going to do a problem eventually where this is a 3 and this is a 2, right? And you can't do synthetic division with quadratic binomials or quadratic polynomials. You have to do long division. So let's do it the same way every time. And let's do this long division problem real quick. Remember, we ask ourselves, what do we multiply x by to get x squared? And that would be x. X times x is x squared. X times -1 is -1x. And we subtract. X squared minus x squared is nothing. That's always going to happen when we do this correctly. And then we do 2 minus -1x. So that's 2 plus 1x, which is 3x. And then we go through that algorithm again. What do I multiply x by to get 3x? And that's +3, right? Now, once I've answered that question, I can stop. Okay, I can stop right now because it doesn't matter what the remainder is. A slant asymptote is a line on a graph, and it's a line in the form of y equals mx plus b. Look at our quotient right now. Okay, what do we have? We have a slope and we have a y-intercept. So it doesn't matter what the remainder is. It doesn't matter how this whole thing shakes out. It doesn't matter if x minus 1 is a factor or not of the numerator. None of that matters. What matters is we got our linear form right here. So right now, we know that the slant asymptote is, oops, sorry. Why don't I actually write down what it is? Yeah. Our slant asymptote is, oh gosh, x plus 3, right? So when I go to graph this, okay, and I'm just going to do this very rudimentary here, this caveman drawing. Okay, when I go to graph this, I'm going to draw a slanted line with a slope of 1 and a y-intercept of 3. All right, there's one of my slant asymptotes, and newsflash, but if I factor the top, I get x plus 1 and x plus 1. And then on the bottom, I get x minus 1. Nothing cancels, so there's no hole. This x minus 1 that remains means there's a vertical asymptote at x equals 1. Watch this. Boop, boop, boop. So here we go. I start to kind of piece this whole thing together, right? And we can stop it there, but you get the idea that we can find these asymptotes. We may have to do a slant asymptote. We may have to do a vertical asymptote, horizontal asymptote. knowing where all of these characteristics are located makes our depth of understanding about rationals much greater. And there's something even better to talk about this asymptotic behavior, but as I've said before, I think it would be difficult to explain in a video, so we'll wait for some class time to go through that stuff. Bottom line is, you have a slant asymptote when the degree of the numerator is exactly one larger than the degree of the denominator, and you find it by doing long division. Think about this, okay? Think about this, if you would, for just one more second. If this is one greater than this, then every time I start this long division process, even if this was x to the fourth and this was x cubed, I would still say, oh, I'm multiplying this by x, right? So that's why we're always going to end up with that linear form at the end, okay? Even if this was 12 and this was 11, I'd say, well, I have to multiply that by x to get that. So that's why we're going to get a linear form on the top, okay?